Okay, so this brings us to the Q&A session for both our invited speakers, Sartash and Ugo. I think there are already some questions in the chat. Now some are coming in the Q&A panel as well. So Venkat, I see you posted a question in chat for Sartash. So why don't you kick it off?
Sure. So thank you. I couldn't post in the Q&A, so I did it in the chat. But the Satash, the great talk. Thank you for that. There, there was your talk about the drone racing, and then there was the earlier talk by Davide. And in these cases, you see that there are these first-person view drone racing competitions that exist, for which there are autonomous equivalents now developing. Are there equivalent ground vehicle racing competitions? I know there's a camel racing competition, robotic camel racing competition in Dubai, but is there like an equivalent ground racing competition? If there is not, why not?
Yeah, there's actually many, I think. So I think there's a few that, like if you're asking human driven, there's like these model cars that many of us play with. I know, people like here do that quite a bit. And there's actually races for that. And, there's like people who are really devoted to that little race, and they'll make like careers out of it. And if you're asking sort of autonomous, there's certainly like the kind of the some of the competitions that we do. Like I did focus quite a bit on the teaching side, but I know that like, for example, Rahul or some of the other people do a lot of work with like at conferences, like a lot of graduate students kind of participate. Certainly some of the students that I teach have been very enthusiastic going out and participating there. And I can see they learn quite a bit actually. So there's maybe like a interesting teaching component there too, but also it's more research oriented too. Like they kind of, I think people implement like very interesting things. So one thing I would highlight is that there's a new DARPA program. There's a new DARPA program called DARPA Racer. I don't know if people have come across, but it's exactly that. It's just kind of racing very fast in like a outdoor off-road environment. But I think calling it off-road would be wrong. Like it's not like you're going on a dirt road. I think it's more like a no-road environment. Like you're just supposed to go like inside vegetation and things like that. So I think that's coming up, and I think it's going to span the next 2-3 years. I imagine it will be very interesting. It's full-size vehicles. There's a company called Polaris that kind of produces these like off-road or no-road vehicles, and so I think that's going to come out. I'm pretty sure it'll be very exciting.
Just to clarify that, yeah, I was aware of the RC car racing community, but at F1 levels, for example, at F1 speeds, was it just me that I was missing that there was a competition that did first-person view racing, or?
Do you mean autonomously or?
No, just at first-person view F1 car, because we talked about
I mean like,
and we talked about autonomy and how autonomy is still
not like having people in there. Yeah. Yeah, maybe. I'm not very familiar that like if there's some sort of like an F1 speed, F1 size, and almost like a first-person view racing. If there is one, I'm not so familiar. Admittedly, even the kind of the model car racing community, it's not first-person view typically. People will be seeing the car like it's going around. It's a very different dynamic.
Yeah, they have usually like a bird's eye view of the entire track. And it's insane that when the car flips over, they know the control is reversed and they can still go as fast as possible.
It's a different dynamic, so you need to be like quite an expert to do that.
Oh, thank you.
Thank you.
So Sartash, there's a couple of questions on the photorealism and the photogrammetry environment that you've created. Antonio, I had the same question, so I'm glad you asked it. So you mentioned this, that it takes a tremendous amount of effort to build this environment, to make it photorealistic. You have to take hundreds of thousands of images. You have to stitch them together. You need
quite a lot.
You need experts in Unity to bring this all together. So do you think there's a middle ground somewhere where you could still operate in a real environment, but use augmented reality and not a fully virtual setup to kind of speed up this process? And the question that was posted was, if you share your thoughts on how you could scale this up,
Yeah, I think
so that others can.
Yeah, these are really great questions. So I'll, kind of quickly answer them if there's other questions for the other speaker also. So I think, so first of all, I think you can do realistic simulations, but at this point, we actually are missing two things. One is that we don't know how realistic the simulation we come up with is. It's kind of very interesting, like how do you find a metric? Like what do you compare? How do you even compare? And so you can make like Turing tests. So you can kind of ask your parents to see if they find a difference. That's always one thing. Maybe you can scale that up, or maybe you can kind of try to like train some AI that you can see if you can fool AI. Even that, I'm not sure if these are like right kind of metrics, but one thing we're missing, certainly, we build things, we can sometimes fool your eyes, but we don't know actually how realistic it is that what people, we don't even know like for what purpose we're doing this ultimately. So you could be fooling somebody's eyes. Is that the purpose, or do you really, I guess we want to do sim to real transfer, maybe that's the main purpose, but how do you quantify it? I think that's one of the missing links. The other link is actually, yeah, how much effort do you put into it? Like what's the right level? And so far we've been trying to do like as realistic as possible. We actually haven't employed everything. So we have some things in the works that will make it even more so, like that kind of basically use some deep learning to replicate what camera images look like. But ultimately you could technically take a little bit less effort and create something. And for the purpose of sim to real transfer, that would probably work. We don't know that. It could probably be very powerful. So we've been working a lot ourselves on augmented reality, the thing that you mentioned. For example, put something like a small model car into an environment, but then render in like something like obstacles into its camera images. That's not as easy as it sounds, because you really need to time things. Like you need to really the camera on board the vehicle and the motion capture, you need to synchronize.
Yeah, you need to register the
yeah,
image.
it's a bit of an effort, admittedly. We discuss it quite a bit in the paper. But sort of like, I think if you can kind of nail that, you would be able to do that. And I think it would still be interesting. So the question is like, what's the goal? And then what do we need? And I think this was a no answer to your question. So I think maybe the better answer is like,
I completely understand.
But,
I think, yeah, both of these.
Sort of like, I think kind of, like you could actually, you're realizing that you could actually go quite far. And I think some of this is not, you're going to see this a lot more. I think that the gaming industry is also stepping this up. Yep. There's a lot of like assets that are scanned out. They're just kind of coming this year. And so you're going to see a lot of like, especially on the Unreal Engine, but also some in the Unity, just kind of like scanned environments coming out. And that kind of answers your second question, how can we scale this? So we did this with a lot of people, for a research lab, but not a lot of people for a company. So if you think about it, like, a lot of companies try to do like, or maybe a lot of people try to do sim to real by putting a lot of the sim to real effort on the training side. So one question could be that, could we put all the effort on the modeling side? We do photogrammetry, we make the environment real and things like that. And then the training side is a lot easier. One advantage of that is that many of the sim to real transfer algorithms are actually complicated neural networks. And so you may be able to create neural networks that are actually a lot more efficient in the inference time as well. So that's an interesting question. Then it just basically comes down to, can you scale? Like, for example, this is 2 floors of the study center environment. Can you go out and scale the city of Boston? I think that with the right of resources, you can. I mean, nowadays, like, people have thousands of employees on like autonomous driving vehicles, like companies, like if you had 200-300 people working on this thing, I think you would, take some reasonable amount of time and create like a good chunk of Boston in real.
Right.
I guess it goes back to what I said earlier. Like, is this useful? And like, I think my answer would be, we don't know. I guess we'll find out.
Yep. Very interesting. Okay, so we have a question for Ugo in the regular chat as well. This question is from Shreyas, and he asks, is the safe set convex hull taken in the full state space or just in the robot workspace? Because there could be potential advantages and disadvantages to both.
Yeah, so that's a great question. So what we did is that we did a change of coordinates. So the state of the system is the lateral distance from the center line of the track. So when you take the convex hull, actually doesn't intersect the road boundaries, and it's taken in the full dimension. So this is like 7 dimensions. But we scale up this approach also for drones. I think one student from the MPC lab actually implemented on a 12-dimensional system.
All right. And let me go through. And okay, so Chris again says he found your work very interesting, of course, and he thought that there were some parallels with the contingency MPC. So not really a question, but more of a comment. Maybe you want to address.
Yeah, thanks. We actually are aware of that, and I guess here the main thing that we try to address is really this partial observability. And so this basically we try to plan in the belief space. So we really try to bring this to a partially observable settings. I believe that the work you mentioned was everything fully observable, but we are aware of this, and we will update, and we will mention in the introduction.
And looks like there's a follow-up to the discussion about the convex set as well. Guan Rui Lee, the question is it possible to select a convex set that makes it infeasible for the optimizer to solve? Also,
okay,
also, what criteria you use to select the local points?
Okay, so actually I didn't have time, but we did a rigorous analysis of the algorithm under some assumptions. For instance, when the system dynamics are known, and when the system dynamics are linear time varying with some bounded additive uncertainty. And so in that case, we were able to show that the strategy that I presented today has some strong guarantees both for safety and optimality and performance improvement. For optimality, we need some technical conditions about the optimization problem, but we were able to show that we converge to optimal, local or global, depending on the problem. And the second part of the question was about
what criteria are you using to select the local?
Yes. So at each time t, we use the previous predicted trajectory to select the point that we're going to use to compute the safe set. And so the key idea is that what we do, we take the last point of the predicted trajectory at the previous time step. And then as that point is inside an invariant set, we can propagate that point forward using a candidate control action. And then we use this new point to compute the safe set. Also want to point out that all the code that we use in the experiment is available open source and is relatively well connected. And please feel free to send me an email if you're interested in replicating all the results that you saw today.
All right, thanks. Thank you, Ugo. So I think we have time for maybe one last question. If I don't know, Johannes, Venkat, Rahul. Otherwise, I have a question for Sartash. Is there going to be a follow-up to the Alpha Pilot Challenge anytime soon?
Yeah, yeah, I guess it's too early to say, but yeah, we're hoping to do one. Okay. And so kind of use maybe like this new environment we have, and if we can align, to be honest, insurance details and things like that, if we can align it, hopefully try to do it at MIT. But it's proving to be more challenging than I hoped. But we're hoping for one. I think that the first one, there were a lot of lessons learned. And I have to admit that I think like we wanted to do something kind of nice and interesting and engage the community. But ultimately, I mean, we did something and people went fast, but I don't think it was like the kind of complicated environments that, you would expect. There's a documentary being produced for the first Alpha Pilot. So hopefully we'll get a chance to like engage the broader public a little bit. And if that happens very well, and if we can align some of the things, hopefully we'll kind of produce something. For example, people will be able to use flight goggles to kind of prep and then maybe try to do something in real. We're trying to pull it together, but I wouldn't want to promise. It seems to be challenging for a variety of reasons.
All right. Well, if there's anyone who can pull it off, it's you. So more power to you, Sartash. Okay. So this brings us to the end of our third and final invited session for the day. Let's thank both our speakers, Ugo and Sartash, for taking our time. I know it's Memorial Day and you were still able to join us in the afternoon.
Thank you to organizers for organizing this amazing workshop. Thanks a lot.
All right.
Thank you.